does let a naysayer know? What is that?
Let a naysayer know.
What?
Length. Hashtag.
The acronym length. What does it stand for?
I don't know what you're talking about.
It means let a naysayer know.
I don't even know what you're talking about. All right. Give me questions about your homework last night.
Number 1.
Yeah, you did 1 through 6. You did not think they were easy? No, Logan.
Did you just go over to this?
Can I do what? Yes. All right, so let's look at number 6 together. Yes, I'll do 5 first, and I'll do 6. So 5, I've got 4w squared minus 11w minus 3, 16w squared minus 1. Since this is multiply, I'm going to leave it exactly like it is, and I'm just going to go through and try to factor any and everything that I can before I start. No, what? All right, so up top, if I factor this, again, this is going to be a slash type problem. So what multiplies to negative 12w squared but adds to negative 11? Negative 12 and positive 1.
They don't give you enough.
So 4w squared minus 12w plus 1w minus 3. What can I take out of the first two? Uh-huh. What's left? Uh-huh. What can I take out of the last two? 1. And what's left? So this factors as w minus 3, 4w plus 1. Are y'all feeling a little bit better about that now? Now this one's a difference of 2 squares, yes? So I get 4w minus 1 and 4w plus 1. How about this piece over here? Can I do anything with that? Yeah, you can. Take out a 2. That's exactly right. So I get 2 times 4w minus 1. And then I have a difference of squares. So I get 3 minus w, 3 plus w. Because w squared minus 9 is not the same thing as 9 minus w squared. Well, it's not. Dozier, your head is blocking.
Yeah, buddy.
Duck down a minute so he can see. Is that better? Okay. All right, so now I need to start canceling out anything top and bottom, right? Because I'm just strictly multiplying. Because this is one big fraction. Where?
So now we're multiplying across.
No, where? You sure?
And now you cross over 4w minus 1.
4w minus 1. 4w plus 1.
Then you do the inverse.
All right, yeah, so look at what I have now because this is where it starts to get a little sticky, right? No. That's okay. That's okay, Noah. Stay with us. I've been watching too much Grey's Anatomy. Okay.
Whoa.
All right. Okay, so look. You notice how it looks like it's very similar, right? They look almost exactly the same. W minus 3 and 3 minus W. But the signs are completely opposite. Here, W is positive. Here, W is negative. Here, 3 is negative, but 3 is positive. So if I could somehow switch all the signs in just one of them, then maybe I could simplify a little bit. So I'm going to take a negative out of these two. It doesn't matter which one you do. I'm going to make that instead of positive 2, I'm going to make it negative 2. And that's going to make this 3 minus W.
And now you can do what with that?
Do you see how we took?
Cost of 3 minus W.
Attaboy, Noah.
I'm not there yet.
We had all four tutoring class now.
No, just one. All right. Yes. Either or, it doesn't matter. It's fine. All right. And then now the next one.
Wait, what happened?
Okay, wait. No, it's not good. No, it's not good.
I'm not good at it.
Help your.
Go back up.
I got it.
Okay, Slade, you gonna help him with that one while I work number 6? Yes, he does. No, I didn't.
We just had to do the 6, right?
W minus 1. 4 W.
Or 7? Just the 7, right?
4 W minus.
4 W minus 1. You put 2 W minus 1.
What?
You didn't put a 4 in front of the W. 8 W, right?
I factored out 2.
Dude, all you do is make the 2 a negative.
No. He's behind that.
Did you factor a 2 out of the top whenever it said 8W minus 2?
He did, but he.
Oh, you can put a 4.
He took 4 out. He didn't divide by 4. He just took that 8.
So now I can cross this.
Now you can cry. Yes. All right, number 6. C squared minus 1 over C to the 4th minus 1 divided by C plus 1 over C squared plus 1. Tell me what you can do. What do you see? All right, so that is what? Why can you do that? He said C minus 1, C plus 1. I probably wouldn't do that first off. Anybody else do something different first off? What'd you do?
I did put 4.
That's what I did too. Not that that was wrong, but for this one, I made it C squared minus 1, C squared plus 1, because at this point, I could cancel this whole top out with that piece. So now I have 1 over C squared plus 1. I'm going to change this to multiply. Go and sit down. And I'm going to flip over that second fraction. What's hard about it? I'm out.
I should do 1. It's just that there's like no number.
Yeah, but look, these are exactly the same, so I cancel them out, and I have 1 over C plus 1. All right. Other questions about your homework before we move on? Yep.
Are we doing complex today?
So when you're here,
No. Maybe.
how do I pull out the -1?
Well,
And
so
where do I
if you
do
just
it?
make this a negative, I just make the number in front of negative, and then it changes all this to 3 minus W. Because negative W plus 3.
Wait, this one's negative?
Yeah. If you make that negative, it changes all the signs.
So now this one's 3 plus W plus 3?
It'd be negative W plus 3. All those signs have to change.
So now what?
Okay, so
Now
negative,
this is
yeah,
this?
this and this are the same.
Oh.
Well, W is negative and 3 is positive.
So then it's like that, and then
Yep.
it's -2 over that.
Yep.
And that's the answer.
That's the answer.
With the proof.
You're done. All right, let's switch gears. Get out your notebook. Stop it, boys. If y'all don't stop.
Notebook?
I didn't do it.
We're on a new thing.
Notebook?
Yes.
Making the 6.
I mean, they don't have to.
Wait,
I would
no.
advise it. We're taking notes.
I don't have to take notes.
So, rationals. All right, guys, let's get serious now. Now we're new stuff. All right, rationals is another word for what? Fractions, right? So if we're adding or subtracting fractions, tell me how how you do that.
Common
That,
denominator.
there you go. We have to get a same denominator, right? That's the only way. Let's just take a basic fraction here. Let's say I need to do a third plus a half. I'm going to somehow have to make the bottoms the same before I can combine them, right? We all agree? And so we have to find a what? A common denominator. And ideally, we won't just find a common denominator. We will find a least common denominator, or an LCD. That's exactly right. So here it would be 6. Now, what is a least common denominator? It's really another word for a least common what? Multiple. That's exactly right. So multiples of 3 being 3, 6, 9, 12, multiples of 2 being 2, 4, 6, and we take the lowest one, right? So here we know it's 6, so we force them to both be 6, which means we give it to the top and the bottom. Yes? So now I end up with 2 over 6 plus 3 over 6, and then how do I combine them? You just put the numerators together and you leave the bottom alone, so it's just 5 over 6. So we're going to take that same concept and apply it to these polynomials, these rational expressions. Y'all ready?
So you're gonna have to find a common denominator of an equation.
Yes. Yes.
That's
I think I know.
All right.
On your left, though. On your left, let's have it.
Let's start easy.
Yeah, I think I know how it is.
Oh, boy.
All right.
Listen.
Listen. What is the least common denominator here? 20W. You don't need W squared, right? I don't need to put them together. They've already got a W. So my LCD here would be 20 W's. Everybody okay with that? So what does the first fraction need? Times 5. What does the second need? Times 4. So I end up with 15 over 20W minus 8 over 20W, which would give me what? 7 over 20W. Easy enough? Let's crank it up then.
Got a question for you.
Today. Tomorrow, and for the test. Okay.
I might forget for the test, so it's probably
What's the LCD?
108.
X plus 4.
X plus 4. But I don't see a denominator on the 3. There's a 1 under there, right? So this is like this. So my LCD is just X plus 4, which means my first fraction is A-OK. It's the second one that needs something, right?
Yeah.
And it needs an X plus 4.
You got 3x plus.
But now wait. Now I have 2x minus 1 over x plus 4 minus 3x plus 4 over x plus 4. There you go. Before I can simplify anything, I could write it this way. I could go ahead and combine these numerators and say 2x minus 1 minus 3 times x plus 4. But remember, when we're simplifying, we need to be factored completely. And so now I'm to the point where I've got this rational expression that's not simplified. So I need to make sure I simplify it. And so to do that, I'm going to need to expand it before I can condense it, if that makes sense. All right, so I've got, somebody said hold up. Are y'all ready? Okay. Well, I didn't need anything on that first fraction because the denominator was already there. Because it already matched my LCD that I decided. Yeah. Yeah, that is a little strong, Logan. You're gonna have to like turn that off or something.
It's really strong.
You and Bertha go ahead.
And you need to sit down because I can't do this.
I will call Teresa.
Teresa can't handle him either.
Yeah, I'm not right here, Logan, calling mom.
All right, does that make sense? Okay. Shh, shh, shh. So now I'm going to be 2x minus 1 minus 3x minus 12 over x plus 4. Because again, before I can get it simplified down, I'm going to have to take it out some. Does that make sense? And now, you're exactly right, Miguel. Now I'm just going to combine like terms. So I got 2x minus 3x, which would leave me with what? Negative 1 minus 12. Nothing else to do there.
Divide by negative
Don't
1.
you dare kill the
What?
But there's 2.
Why is it what?
Don't you dare kill the kitten.
Well, you're distributing that negative 3 through.
And then we just combine like terms.
Yep. Mm-hmm.
Can you feel the kids here with me?
All right, no killing of kittens, but we are going to crank it up another notch.
There's no notch.
There is a notch. That's the answer.
How did it become one fraction?
Yeah, when you add fractions, the denominator's the same. You keep it and leave it alone, and you just add the top. Or just combine the top.
Okay.
I just go down. I don't like when.
I do too.
Yeah, you have infinite space.
I do. It's not, I don't know. Everybody's like, squirrel today. I don't know what's going on. Ready? Logan, hush. We can't even get to, like, this is still this is pre-algebra 2, really, so far. The rational equations are when we get to the algebra 2 stuff. But that's okay. It's okay. So, all right. I want you to look at this one for a second. Don't blurt it out, Slade.
No way. No way. No way.
All right, don't say it, but I want you to look at this for just a minute. Miguel, what is LCD?
Yeah.
It's the least common denominator.
Logan.
Just because it's good the last name was one of the closest.
Logan, I'm sitting down. You're doing something wrong.
All right, what'd you figure out? Before you actually combine them, what do you know about the LCD here? Common denominator, what do you think it is? I hear different stuff. Hannah, what'd you say you think it is? So you think it's R minus 5? Okay, let's go along this thought process here. Let's say this is difference of 2 squares. This is R minus 5, R plus 5.
No,
You can put it in parentheses.
this one you can't cancel.
Oh,
Yeah.
what do you say about killing a kitten?
What is the common denominator? It's already there, actually. It's just the R minus 5. So this would just be 7 over.
Oh,
What? Yes, I can.
It's just, it's in that individual fraction.
Why can't I?
It doesn't matter. If it's in that individual fraction, you can still do it.
Yeah, I'm a
Shut
go.
up. Yes, I can. Yes.
That is,
Oh my gosh.
Right about.
Wait, what was the answer?
all in favor of banishing slaves.
Send him the
Come
road.
on, Puerto Rico, raise your hand.
All right, try
Is
it.
there a capital A?
That's a 4. All right, I'm not going to tell you the answer. Don't blurt it out. Try this one on your own for just a second. I'm going to pause this for a second while y'all cook. That I would do as I look at this is I would factor any and everything that I can. Okay, that's always a good first step in anything that you're doing. So as I look at this, I see a difference of 2 squares here, which is a minus 2, a plus 2. Okay, but you got that far, so that's okay because that's progress. That's a step. That's right. So now I need to form an LCD. Now here, whenever I just have no idea how to do the LCD, here's the way I go through it. I'll come over to the side and I'll write it. I'll say, okay, LCD. I'll take the entire first denominator. A minus 2, bless you, a plus 2. Then I'll move to the second denominator and I'll say, okay, it's got an a plus 2. Do I need that in the LCD? Do I need that piece? It's already there, right? So I don't need another one. So I'm not going to include it. If I didn't have it, if this was maybe, say, a plus 7, then I'd come over here and add an a plus 7. You see what I'm saying? If I need it, add it. If I don't, move on. Because eventually we'll get to where we're adding 3, 4, and however many pieces together. Okay? So finding that LCD is important and being able to do that. Does everybody understand where I'm getting this LCD? Okay. Now I stop and I go, okay, give everybody what they need. Okay, well, first guy's got everything he needs, right? He's got the whole LCD. But the second fraction, he's missing something. What is he missing? A minus 2. So I need to give him what he's missing. Because everybody wants the same thing. Okay? Now everybody has the same bottom. Do you see that? So now I'm ready to combine the tops. So I have 5a plus 6 minus, and be careful with this minus because it's subtracting everything up here, minus a minus 2 over a minus 2, a plus 2. And remember, my goal is to be completely simplified in the end, which means I need to combine like terms and see what else I can do. What do you mean? The denominators? Okay, now the other one did just because there was something up top to start with. There was nothing up there really to cancel it with, so yeah. Oh. Absolutely. Yes, you have to distribute so that this is 5a plus 6 minus a plus 2. And now I can kind of gather some stuff together, what I need to put together. Then multiply by each other. All right, so I got 4a plus 8 over a minus 2, a plus 2. Except that that's not it. That's correct, Miguel. Why is that not
Because
it?
you can factor out something from the
I got to factor out what I can. I can factor out what? Where? Here? Because that's not in a parenthesis and it would kill a kitten. That's not in a parenthesis. Every plus or minus. Don't or do? Oh, look how nice and lovely. There's your A plus 2s you wanted to cancel out. There's your. That's not right.
5A plus 5 is.
That was close.
No.
What was it?
A minus 2.
Absolutely. Just use your motivation never to.
Say it again. I was trying to listen to help you, but I couldn't hear. Yeah.
How did it turn?
So, you understand this up to here? Which part did you get lost on? This part? After that, here. So, I took a GCF out of the top. They both had, I could divide them both by 4 up top. So I divide them by 4 and it left me with A plus 2. So before you can start marking things out, all your plus or minuses have to be inside of parentheses. You can't just mark out, like I can't just come here and start, I can't mark that A minus 2 out with that A minus 2 because I've got some parentheses there that aren't. In order to start canceling everything, it has to be something times something times something. Well, here I've got something plus 6 minus, and then there. I have to get it to where it's just a multiplication problem. Well, because whenever I pulled that 4 out, look, there was an A plus 2 on the top and bottom. Because at this point, all my pluses or minuses happen inside parentheses, which means I can start to strike things out if I need to. Does that make sense? A little. Let's try another one. All right. Y'all ready for this one? Noah, this one's for you, buddy. I'm going to use an X. They've got a Q on here. I'm going to use an X. It's a little awkward. Did everyone at least factor that quadratic first? Yes. I don't know if you have to or not. No, you should just combine like terms. What'd you get for your LCD? That second denominator, right? That entire second denominator. So the first fraction is missing what? X minus 3. So I give it to it. You got to give it what it wants. It wants the rest of it. And we gave it to it. So now we're ready to expand it a little bit so that we can simplify it back down. Now, this is where I was telling you. Up top, you have to expand before you can condense it down. So I'm going to have to FOIL that out. And that stinks. But
That's what I did.
no, because remember, before I can combine them, they have to have the same bottoms. The whole point in putting the X minus 3 top and bottom was so that the bottoms were the same. If I cross them out now, they won't have the same bottoms. I'll be undoing what I just did, if that makes sense. No, it doesn't matter. You still should come back to x squared minus 2x minus 3 when you simplify it.
Oh, yeah.
I've got that minus all of this, and everything goes over x minus 4.
So then what do you do?
Yeah, I'm going to go through.
Then you just combine like.
But are you not subtracting this whole fraction? That's a yes. Say yes because you are. Yeah. If you multiply it out, if you had x minus 3 times x plus 1, you get x squared plus x minus 3x minus 3, which is still, that's not true. You just missed it. All right, so I'm still not done. Do what? Yeah. This is going to become minus x plus 1, right? So now I've got x squared minus 3x minus 2. And now I need to factor up top to make sure nothing cancels at this point. In other words, look, the leading coefficient's 1, so it's a shortcut factor. What multiplies to -2 but adds to -3? No, it doesn't factor. Nothing factors. It doesn't factor. I stop. Did you get it right? How many of you got it right? Start to finish. A couple of you. Good job. Okay, so because here, remember, since this is subtracting, I have to subtract everything up top. So that became -x plus 1. I distributed that negative sign through. Yes. Essentially, yes. Yes. This one's going to look easy, but you're going to get into it, and it's not going to be as easy as it looks. Are y'all ready? You're welcome. I just didn't want you to see it and said, I thought you were going to do another one, and that's easy. Last semester that was white. Butterfly it. You remember that? White was always butterfly it. Butterfly it. No. No, it's nothing.
I got him.
I stumped you on this one? Can I factor anything? Everything's factored completely. Write the first denominator. Yes. I need the whole second denominator. So what does the first fraction need? X minus 1. What does the second fraction need? X plus 6. Now I can combine them both over the same denominator. Now can you clean it up and simplify it? I can't factor it, I can't do anything else, so I stop.
Yeah, but it's distributed.
3 times x minus 4 times -1 like that. One distributed.
You're on. So.
Yeah.
Oh, it is right.
-2.
There you told me.
I'm just getting my signs wrong. I just been getting my signs wrong. Those are helping you.
You pick your seat. You can sit wherever you like.
I've been helping. I got my sign wrong one time. That one was
That's it.
that was easy.
Okay, well, we don't have to practice.
It was a harder one.
I am going to show you complex fractions. It'll be quick.
No, we understand.
It's the same thing. You haven't seen it to know if you understand it. It is the same thing.
This one? Is this easier?
Oh my god.
Is this easier?
This is still adding or subtracting. That's why it's always included in adding and subtracting.
This is a
This is what we call complex fraction. Okay, they're fractions in fractions, but it's exactly what we've been doing. If this was something new, I would not throw it in with today, knowing that you've struggled. But here's what we're going to do. We're going to look at this as 3 separate problems. Try what? I haven't shown you what to do. Yes, we're going to work the top as one problem. We're going to work the top as one problem. Then we're going to come over here and we're going to work the bottom as a second problem. And then what we're going to do is we're going to take the top and instead of dividing by the bottom, because that's what we do, right? We do top, we're just going to do top times flip of the bottom.
This next. I'll figure it out.
All right, so let's look at the top first. Now look, whenever I do these problems, I literally divide my paper into 3 columns, and I put top, bottom together. It will make your life easier.
all right this time.
Well, I mean, I would have been writing all of this stuff down that we've been doing, but it's up to you. So looking, for example, is the top. This is just what we've just been doing. Look, there's nothing new there. That's combining, subtracting rationals. What's the LCD? Look, guys. My LCD here is 40R squared. Bless you. Bless you. What does the first one need? If you can. It needs 4R squared. 4R squared. These tend to be easier than just the adding and subtracting ones because they're not quite as involved. So now look what I have. I have 4R squared minus 9 over 40R squared. How many is all right, well, I need to simplify it, right? So that's a difference of 2 squares. Do y'all see that? So 2R minus 3, 2R plus 3. What is that about?
The rectangle.
This is a complex